Write the following in decimal form and say what kind of decimal expansion each has. 36 by 100. Well, 36 by 100, we have learned division by number followed by zeros, like division by 10, 100, 1000, and so on. In division, we shape decimal 2 places left. So the first part, 36 by 100, can be written as 0.36. Well, so what kind of decimal expansion is this? This is terminating. Terminating decimal expansion. So part 1 is done. Let's see part 2. Part 2 is 1 divided by 11. So divide 1 by 11. See, 11 and 1. 1 is not divisible, so 0 point, it gets 10, still not divisible, so you put a 0, and now one more 0 is increased, and then 11 9 99. Look, when you subtract, you get again the same number 1. The number, it was 1 by 11, no? You get the same as the numerator. Means the same process will get repeated now. Again, 1 is not divisible, so you will bring down 0. Not divisible, put 0 in numerator. One more 0 down, so 9 times. So this process will continue forever. Again, remainder 1. So we can say that this 1 by 11 is a non-terminating decimal expansion, and it's repeating itself after 2 digits. So 1 by 11 can be written as 0.090909. It will continue like this, no? 09. So we can write dot dot dot. And we can also write it 0.09, and we put a bar over these two digits. That means these 2 digits are repeating over and over and over again infinitely. All right. So the second number, what kind of decimal expansion is this? It is non-terminating but repeating. Non-terminating and repeating. Next part is 4 1 by 8. This is third part. 4 1 by 8 means 8 4 32. 32 plus 1, that is 33 by 8. Divide 33 by 8. What you get? 8 4 32. Same as this number. 8 4 32. And then subtract, you get 1. Not divisible, so you can put a decimal. After decimal, you can increase 0. 1 0 increase, it is divisible 1 time. So 8 1 8, subtract 2. After decimal, you can again increase 1 0. 8 2 16, subtract 4 0, and 8 5 40, and finally you see that remainder is 0. So when remainder gets 0 after certain number of terms, we say this is a terminating decimal expansion. Value of this number is 4.125, and we say this is terminating decimal expansion. Okay, let's take next part, part 4. Part 4 is 3 divided by 13. We will normally divide 3 by 13 and let's see what we get. So 3 here, not divisible, 0 time, and then it gets, we can increase 0 after placing decimal there. So 1 0 and 13 2 26. Next, 4 is the remainder when you subtract. Then you can bring down another 0, so 40 and 13 threes, 13 threes, 39. Subtract, we get 1. Bring down 0. After decimal, you can bring as many zeros as you want, right? So 10 not divisible by 13, we put a 0 and bring down another 0. All right. Now 100 is divisible by 13. That is 13 7. Yes, 7 times 91. Subtract, we get 9 and 0. 6 times 78, 13 6 is 78. Yes. And then 2, subtract. All these numbers get subtracted, no? 2, 1, and bring down another pair, another 0. So 120 and 13. How many times? 9 117. Look, when you subtract this, you get back the same number 3. Look, this 3, number 3 is now being repeated. 3 number was there, and these all steps happened after that. So the 3 is here. That means these all digits will repeat again. Means this block of 6 digits, 2 3 0 7 6 9, are going to repeat it over and over and over again, right? So we can say 3 by 13 is equal to 0.2307669, and these all number, 6-digit number, will repeat 2307669 and 2307669, and continue like that. So in short, we can write 0.2307669, and we place a bar over it. Bar over these 6 digits mean these 6 digits are repeating over and over and over. So what does it mean, this decimal? What kind of decimal expansion is this? This is non-terminating, of course, because it is not ending. We are not getting remainder 0 ever. So we will write non-terminating, non-terminating, and but repeating. Non-terminating, but the digits are repeating, no? Repeating. All right, so this is part 4. Now we will see part 5. In part 5, you must write all together while you're watching. I strongly recommend you write these numbers. The next one is 2 divided by 11, right? So again, divide 2 by 11, not divisible, 0, place decimal, and then you can increase zeros. 20 is divisible by 11. How many times? 11 1 11. Now subtract. What do we get? 11 9. Increase 0. 11 8 88. Yes, subtract. 2 is the remainder. See, this number 2 is repeating. That means this one, again, this thing will continue now. 20 So 1 time, 11, 9, 0, 8 time, no, 88, again 2. So this is going to be continuing like this, 1, 8, 1, 8, 1, 8. So we can say 2 by 11 can be written as 0 0.181818, right? And we can also write it 0.18, and we put a bar over these digits, mean these two digits will keep repeating forever. 0.18 and you put bar over it, it means this is a decimal expansion of 2 by 11 is non-terminating and repeating. So that's right, non-terminating and repeating. All right, so this is part 5. Next is part 6, which is 329 divided by 400. So let's divide by 400, and this number is 329. Of course, 329 is smaller than 400, so well, it is not divisible, so we write 0, then we increase 1 0 there. 8 time, because 4 8 is 32, so it is divisible 8 times 3200, and then the difference is 90, and then you bring down 1 0. 900 is divisible by 400, or you can say 9 is divisible by 4 2 times. 4 2s are 8, we simply increase 2 zeros, and the difference is 100. Now we bring down 1 0, since we have placed decimals, so we can bring zeros in order. So 10, 4, 10 is divisible by 4 2 times. 4 2s are 8, and then you put 2 zeros, subtract again. Now 200, bring 1 0 down. Now 20 and 4, so that is divisible 5 times. 4 5s are 20, simply increase 2 zeros, and the remainder is finally 0. That means in sixth part, you can say this is 329 divided by 400. It's same as 0.8225. It means, as we can see, since the remainder is we getting 0, that means this number is the decimal expansion of this rational number is terminating decimal expansion. So simply we write terminating, means decimal expansion of this number terminates after certain number of steps.